Hello friends, in this video we are going to discuss about the second numerical related to the buck boost converter. Okay, so let us read the example. The buck boost regulator has an input voltage VDC. Okay, is 12 volt. So it is given that input voltage is equal to 12 volt. The duty cycle D is equal to 0.6. D is equal to 0.6. Next, the switching frequency f is equal to 25 into 10 to the power 3 hertz. Okay. Next, for the inductance L is equal to 250 into 10 to the power minus 6 Henry. For filter capacitance C is equal to 220 into 10 to the power minus 6 Farad. Okay. For the average load current, yes, it is given that I0 average is equal to 1.5 ampere. Okay, determine the average output voltage V0, the peak to peak ripple voltage delta V0, peak to peak ripple current in inductor delta IL, the peak current of the switch, the critical values of L and C. Okay, these things we need to find. Okay, so first thing is F is given. Okay, so from this can we find T? So T is equal to 1 by switching frequency, so it is like 1 upon 25 into 10 to the power 3. Okay, so it is like 1 by 25 into 10 to the power 3, so means 0.04 into 10 to the power minus 3 seconds. Okay, this is the T. Okay, now for the first bit, yes, for the first bit we need to find the average output voltage, so V0 average. If you check for buck boost converter, what is the V0 average? It is a D upon 1 minus D. Okay, into VDC. Okay, D is given, it is a 0.6, so it is equal to 0.6 upon 1 minus 0.6. Okay, into VDC, right? What is the VDC? That is the DC input voltage. Yes, it is given that 12 volt, so into 12. So from this we can write it as 0.6 divided by 0.4. Okay, into 12, so it is equal to 18 volt. Okay, V0 average is equal to 18 volt. V0 average is equal to 18 volt, right? Answer for the first bit. Next, the peak to peak ripple output ripple voltage delta V0. Okay, so next second bit we need to find the delta V0. So if you check, we already derived the expression for the delta V0. Okay, so second bit delta V0 is equal to, yes, delta V0 is equal to, we are having the expression dt into I0 by C. Okay, D into T into I0 means I0 average divided by C. So D is 0.6 into T, that is the time, it is a total time. Okay, 0.04 into 10 to the power minus 3. So it is a 0.04 into 10 to the power minus 3 into I0 average. Yes, I0 average is given, it is equal to 1.5 divided by C. Yes, value of the capacitor is also given. Capacitor value is equal to 220 microfarad. So it is a 220 into 10 to the power minus 6. So from this we can find delta V0. So if you check, it is 0.6 into 0.04 into 1.5 into 10 to the power minus 3, right, divided by 220 into 10 to the power minus 6. So it is equal to 0.1636. Okay, 0.163 volt. This is the delta V0 we are having. Okay, next third bit they have asked for. Yes, if you check the third bit, the peak to peak ripple current in the inductor. Okay, that is a delta IL. Delta IL they have asked. Okay, so delta IL is V0 into 1 minus D into T. Okay, so it is a 1 minus D into T into V0, right, divided by L we are having, right, divided by L. Okay, 1 minus D into T into V0 divided by L. Okay, so now if you check, it is like 1 minus 0.6, right? D is given, it is equal to 0.6. Okay, yes, D value is 0.6 into T. T is equal to 0.04 into 10 to the power minus 3 into V0, right? output voltage we have calculated, it is equal to 18, right? V0 is nothing but V0 average only. Okay, so it is into 18, right, divided by L. Inductor value is given, it is a 250 microhenry. 250 into 10 to the power minus 6. Okay, so if you check, it is equal to 1 minus d into t into V0 average, right? So it is 1 minus 0.6, so it is a 0.4 into 0.04 into 10 to the power minus 3, okay, into 18 divided by in bracket 250 into 10 to the power minus 6 is 1.152 1.152 ampere. This is the delta IL we are having. Okay, so this is for the third bit. Next, in the fourth bit they have asked the peak current of the switch, right? Peak switch current. So peak switch current, peak value of switch current. So if you check the peak value of the switch current, right? So when switch is in the on state, okay, so ISW peak is nothing but what? If you check for the buck boost converter, when the switch is in the on state, at that time the peak value of the inductor current is nothing but the peak value of the switch current, right? So is nothing but IL peak only, right? And what is IL peak? Yes, we are having IL peak is equal to IL average, right, plus delta IL by 2, right? IL average plus delta IL by 2. IL average plus delta IL by 2. Okay, so what is IL average? Yes, we are having IL average is nothing but we have derived it. Okay, I0 upon 1 minus d. So it is a I0 upon 1 minus d. What is this I0? I0 is nothing but I0 average. Okay, so it is a I0, can write it as a 1 minus d. Okay, I0 average upon 1 minus d plus delta IL by 2. Okay, plus delta IL by 2. Okay, so what is the I0 average? Yes, I0 average is 1.5 upon 1 minus 0.6 plus what is the delta IL? It is a 1.152 divided by 2. Okay, so from this we can write peak value of the switch current is equal to 1.5 divided by 0.4, okay, plus 1.152 divided by 2, that is 4.326 ampere. This is the peak value of the switch current. Next, the critical values of L and C, the last bit, the critical values of L and C. Okay, so L critical is equal to, yes, we are having the expression for L critical and the C critical also. Okay, so in the L critical, yes, it is equal to R into 1 minus D bracket square into T divided by 2. Okay, next, what is R? R is nothing but whether R is given, no, right? But we can find it is V0 average by I0 average, right? I am going to replace R with V0 average divided by I0 average. Okay, into it is a 1 minus D bracket square into T. Okay, divided by 2, right, divided by 2. So from this we can write it is equal to, yes, V0 average is 18. Okay, 18 divided by I0 average is 1.5, so we can write it as 18 upon 1.5. Okay, into it is 1 minus 0.6 bracket square into T is 0.04 into 10 to the power minus 3, right? If you check T value, it is equal to 0.04 into 10 to the power minus 3 divided by 2. Okay, so from this we can write L critical value is equal to, yes, 18 upon 1.5, right, into 0.4 square, okay, into 0.04, okay, into 10 to the power minus 3 divided by 2. So it is 38.4 microhenry. 38.4 into 10 to the power minus 6 Henry. This is the L critical we are having. Critical value of inductance, right, that is required in the circuit. Okay, critical value of inductor means it is like a IL will be just continuous. If we put L value is 38.4 microhenry. Okay, and next C critical. C critical, that is the critical value of capacitor, right, is equal to, yes, we're having the C critical is equal to, expression for C critical, it is equal to dt upon 2r, d into t upon 2 into r. Okay, so d is 0.6, t is 0.04 into 10 to the power minus 3 divided by 2 into r. R is v0 average upon I0 average. Okay, so we can write it as is equal to, yes, 0.6 into 0.04 into 10 to the power minus 3, right, divided by 2 into v0 average is 18 divided by I0 average is 1.5. Okay, so if we put this, yes, and if we check, it is equal to 0.6 into 0.04 into 10 to the power minus 3 divided by 2 into 18 divided by 5. Okay, 3, 1.5. So it is equal to 1 into 10 to the power minus 6, right, it is a farad. This is the value of C critical. Okay, so if we put this value of C, okay, then we will be getting the VC waveform or the V0 waveform. It will be like a just continuous, right? Okay, so this is about the second numerical related to the buck boost converter. In the next video, we are going to discuss the numerical number 3 related to the buck boost converter. Thank you.